Hello and good evening to everyone. Thank you for joining me for this another presentation with Gert van den Bosch. Now, listen, I have such a privilege to be able to ask Gert when he's come up with new thinking, come up with new concerns, to be able to reach out to him and say, Gert, can we have a chat? I've been talking to him since March 2021, and what a tremendous privilege it has been. And so Gert's concerns I always listen to very carefully. And I'll say that when you look at the transition of the pandemic, I can't see where he got things wrong. You can argue about timing, but certainly what he predicted with regards to the viral variants has come true. Why would I doubt him now? So, but before I start, I just wanted to remind everyone that in the description is a link to an upcoming project that I'm working on with dementia, which is about disease X, whatever that is. Now, in some cases, I think this will be another variant of COVID, not necessarily anything new, but it could also be influenza. And so there is a link in the description if you want to join us, if you can sign up for that. And guess what? I have as many of the videos and interviews that I've done with Gert over the past few years, and you can see them all here, including with Malone and with Dr. Chetty. And so this is quite a collection of interviews. They're all available, but they're just not necessarily easy to find. And so, yes, if you're interested, please click on the link below and we'll be happy to discuss further things with you. But without further ado, let's bring to the stage Gert van den Bosch, and I'll make sure your mic is unmuted. Gert, for some reason, oh, there you are.
Yeah,
So, Gert, as normal, I'll ask you to do a quick introduction of yourself.
yeah. Thanks, Philip, for having me again. And yeah, the introduction. So my background is veterinary medicine. After a relatively short clinical trajectory as a veterinarian, I switched to human diseases, molecular biology, and immunology at Robert Koch Institute at the Free University of Berlin, and specialized in virology. Did my PhD in virology. Spent also several years in environmental virology, and then went to work with industry. Three big vaccine companies where I was primarily involved. Well, first of all, in late development, so there was very close to the product, to the clinical development, also regulatory quality control, etc. But then switched to early development, R&D department, specialized, in fact, in adjuvants and alternative vaccine delivery, set up as a premier, I think, in the vaccine field, a lab for biophysical analysis of vaccines to better understand the interaction between adjuvants and antigens and so on. And after having spent 12 years in the vaccine industry, I then moved on to the Bill and Melinda Gates Foundation, where I was a senior vaccine officer, senior program officer in vaccine discovery, where I got involved in many vaccine projects, of course. And after 3-4 years at the Bill and Melinda Gates Foundation, I then came back to Belgium, set up my own vaccine company and consultancy business. Went on to work with Gavi, the Global Alliance for Vaccines and Immunization in Geneva, where I was the Ebola program manager. So that was about 10 years ago, yeah, the Ebola crisis in West Africa, where I was helping to coordinate the efforts of the public health efforts in that regard, with vaccines involved, of course, from pharmaceutical companies. And yeah, after all that, I think I continued my development of natural killer cell vaccines, which I thought was very exciting and probably still relevant. But then all of a sudden, the corona pandemic broke out, and yeah, I got completely involved in this. Certainly, as soon as I heard that the plan was to do during this very pandemic mass vaccination in people. Over.
Yeah. So, Gert, I think an important thing to deal with, because I think that based on the comments that I'm seeing from people, so many people are turned off about vaccines generally. And how do you feel? Because the vaccine industry is your lifeblood. Do you at all feel as though you've let the side down by asking questions? Because, in effect, by asking questions, you're challenging, or to people's mind, challenging vaccines in totality.
Yeah. Well, in fact, it's very very strange to say, but I've been always, I've always been going to vaccine congresses and telling people, look, there is this anti-vaccine lobby and a big movement. We cannot ignore this, and we should not ignore this. And I've always been calling for doing a better job, making vaccines more safe, using completely different concepts. As, by the way, that what I've been doing with the NK cell vaccines. So, but I must say, after the COVID mass vaccination initiative, I've also revised, of course, my opinion with regard to a number of vaccines. But I'm still very much in favor of a number of vaccines, for example, the childhood vaccines and the childhood immunization program that is using live attenuated viruses that do, of course, stimulate cell-based innate immunity. All what I'm always saying is that we should find ways to make vaccines more safe. So can we have vaccines that can stimulate cell-based innate immunity, for example, without the need to use live vaccines, live attenuated vaccines, because we know in certain cases where, for example, children or immune compromised, or that they can develop disease and even severe disease. And I'm certainly not denying that there's also causes of autoimmune disease, which also occur during natural infection. So we need to do a better job. And I hope there will still come a time where we can fundamentally review this whole vaccine business. It's clear that when it becomes very lucrative, then of course industry starts to push for many vaccines, for more and more doses, for very different vaccines, for all kinds of diseases. And it's very clear that there is not always a need for this. So we need a complete rehaul, and we need to revisit this completely. I don't think we should abandon the vaccines, not at all. But there is certainly a lot of work to do. But as I was just pointing out, I've been calling out to do a better homework already 20 years ago. Over.
Yeah. So, as we come now to where the pandemic is, because this is what our viewers are interested in, they are concerned, or some people aren't concerned about where we are. And you've said some very big statements, and I just want to make sure that you can clarify them. And so I'll bring up at the top of your paper here: nature will unambiguously demonstrate that neither the unvaccinated nor the vaccinated who refuse to revaccinate can be blamed for the imminent transition of this immune escape pandemic to its final hyperacute phase. Now, before I ask you to respond to that, Gert, you do realize that there are some people who still disagree that vaccines are the primary driver for viral variants. What are your thoughts on that? Even after 4 years or 3 years, and we're seeing all kinds of variants appearing in highly vaccinated regions. People still don't believe that this is being driven by the vaccinated. What would you say?
Yeah, well, what would you say if these are really, I would say, professionals, virologists, vaccinologists? Frankly speaking, I cannot understand because I'm not the first who is documenting immune escape. And frankly speaking, the biggest enemy of vaccinology is immune escape, is the immune escape of the pathogen. So, but of course, I can understand that lay people decline this because they are saying, yeah, the vaccines got recommended and the public health authorities are knowing what they are doing, and they don't even want to probably to listen to what I have to say. So, in that regard, I can understand. All I can do is what I've been doing in the previous years is sharing my knowledge, my insights, and also point to the logics in what is
Have we lost
reality.
Gert? Oh, yes, there you are, Gert. We just seem to have lost you just for a
Oh, did you
second.
still hear me? Did you still hear me?
Just for about 10 seconds, I think, right before you appeared back on
No.
the scene. But yeah, not to worry. I want to just quickly, before we go on into talking about some of your predictions, I want people to understand a few images as to what we're talking about. And so, in order to do that, I've got this paper here. This paper is now about 6 months old, talking about neutralization escape with the variants. And the reason I like this paper is because it has some nice images in it that will help people to understand what you're talking about. So here is the spike protein. I'll make this big screen temporarily. This is the spike protein from different angles. This is front, this is switched around the back, and this is looking at it from the top. And you'll hear Gert talking about the N-terminal domain, and this is what they look like in purple. This here from the top is the receptor binding domain with the yellow and the green and the blue and a little bit of red. And this is what the spike protein looks like on a virus. And there are multiple spike proteins on a single virus, and they're usually stuck in the envelope. So the bottom part here, so the top here is S1, the bottom part here is S2. And what's interesting in this picture, this was looking at the BA286 mutation. And wherever you see red in this image is where all the mutations have occurred from the original virus. And this is why you end up with different variants as it continues to mutate. And so this is BA286, which is just before JN1. And it's showing you in red all of the mutations, which primarily are on the S1 and the receptor binding domain. Anything you'd like to add to that, Gert, when what I've added with that picture? Gert, did you hear me?
Well, partially, it's the first time this is happening, Philip, that it gets interrupted very regularly. I don't know why. I checked my internet connection. It's
Mhm.
normal. So I don't know what's happening. Yeah.
Yeah,
Yeah,
so
I heard most of what you were saying, so there's no need to repeat it, Philip.
yeah, so I guess in terms of now, what it is that you are concerned about, I was just showing people to understand the spike protein. What makes you very concerned at this point with the transition of the pandemic? Because you were concerned at Christmas. Are you more concerned now, or what are you? What's the difference?
Well, I'm now, highly concerned. I'm personally, in the highest state of alarm, if you like, without panicking. And because and the reason is that what is happening right now is literally completely aligned with what I've been predicting in a sense, some people who, have seen my book or read it or just, the front page, have seen that one of the subtitles was or is that highly vaccinated societies will be caught by surprise, will be caught off guard, because it will all happen in a very insidious way. And that can be completely explained by the immunology. But let's first say why or why it is so insidious. Because if you think about acute cases right now of COVID-19 disease, and if you think about hospitalization rates due to COVID, of course, and mortality rates, they are still pretty low. And of course, the titers in wastewater are fluctuating, but they are still relatively low as well. And so many people think this is completely over because there is no longer really very significant suffering from the acute COVID disease. And that can be explained by the fact that, I'll take it a shortcut, but I think people will understand at the beginning, as you just pointed out, Philip, the antibodies were targeted at spike, even at a very particular domain of spike, the receptor binding domain, right? Most of the neutralizing antibodies were targeting the receptor binding domain. But then we started to have the vaccine breakthrough infections. Remember, after Omicron came, we had vaccine breakthrough infections. And the vaccine breakthrough infections, what they did, in fact, was that they were eliciting another type of antibodies, namely what we call broadly neutralizing antibodies. And the first antibodies against the receptor binding domain were very specific, very much targeted at that variable domain of spike, whereas the antibodies elicited after the vaccine breakthrough infections were targeted still at spike, but at more conserved domains. So that means domains that were shared with many other variants. And therefore, we call them broadly neutralizing.
I think, Gert, I think I'm going to
The
ask.
Yeah.
Gert, can I ask you a favor? You're lost again. What you do is jump out and jump back in. And whilst you're doing that, I will show the audience some of the things that you're talking about with the
So I
conserved.
should leave the studio and then
Yeah, and then
bring
come
it
back
again.
in. Yeah.
Okay,
Mhm.
great.
Yeah, so one of the things that Gert had in his paper was that he was talking about these highly conserved universal peptides. And he has here in this image here all of the different viruses. So this is SARS-CoV-1, this is an antelope coronavirus, a giraffe coronavirus, a bovine coronavirus, an equine one. Over here, there's another group. And what you have to look at is this sequence here about SAIEDLLF. And this sequence is what he calls the universal peptide. And this is in place across all of these viruses. And critically as well, this is in place with regards to MERS. This we discovered in 2012. And it's also present with regards to SARS-CoV-2. It's very, very well conserved, and it's on the S2 portion. So when you look at the spike protein, it will be somewhere in this part here of the spike protein, very well conserved. And this is what he's talking about. So I was just giving that explanation, Gert, about the universal peptide. Do you want to expand on that a little?
Well, it's good that you explained this, Philip, because it fits well in what I was just explaining, namely that the immune response of the host, of the population, along with, of course, the evolution with the virus, changed as well, from very specific neutralizing antibodies to broadly neutralizing antibodies. And the next step is that these broadly neutralizing antibodies, they became also less and less efficient. And what happened, in fact, in terms of immune refocusing, is that ultimately the immune response that is now controlling the infection in the vaccinees, or the ctl response that you just explained. So these are T cells that can kill virus infected cells. So interestingly enough, the immune response that is elicited after the virus has adapted and evolved is always a little bit weaker. So that means the broadly neutralizing antibodies are not as good or not as strong as the specifically neutralizing antibodies. The cytotoxic T cells that are eliminating virus infected cells are not as good as the antibodies. Why? Because the antibodies have to catch the virus, to neutralize it, or to prevent.
Can you hear me, Gert?
Yeah, I can hear you. Yeah.
Yes, you just cut out again about the cytotoxic T lymphocytes being able to neutralize. Let me just make sure I got it right. So the cytotoxic T cells that will target the infected cells are not as efficient as when you have targeted antibodies
Yeah.
binding to let's say, for instance, the
Well,
spike protein.
well, that's very easy to understand. In fact, they are very efficient, but they come, so to say, too late because they can only kill virus infected cells when, of course, the cell is already infected. So they have not a preventive effect, right? Antibodies can, of course, neutralize or inhibit the infection, prevent the virus from entering into the cell. The cytotoxic T cells can only start to control virus infection once the virus entered already in the cell and started to replicate. Then the ctls, the cytotoxic T cells, can recognize those cells and kill those. So, but it shows very clearly that the more the virus is evolving, the more the immune response is allowing the virus to continue to replicate, to continue to transmit. So the responses, or the immune responses, are no longer optimal, they are suboptimal, and all they do, in fact, is that they drive immune escape, that they promote immune escape. But nevertheless, and here comes the connections with the connection with the clinical symptoms, the fact that these ctls can still kill virus infected cells explains, of course, why these people, despite being infected, will clear the virus pretty rapidly, and they will start to get symptoms. But before the symptoms can really manifest, the cytotoxic T cells will kill those virus infected cells, and these people develop mild or even kind of like asymptomatic disease. So that is very, very insidious, because the virus is continuing asymptomatically, because people are no longer aware that they have the infection, because they do not really develop symptoms. The virus, on the other hand, is highly infectious. So these things combined, the fact that there is less and less clinical symptoms, fewer and fewer clinical symptoms, and that the virus becomes more and more infectious, explains, of course, why the virus is still spreading like wildfire, and that the pandemic is anything but over. So, if you can still hear me, Philip,
Yes, you're still here.
what is important when you showed the universal peptide is that the universal peptide, the word says it, universal. This is not only shared amongst several different variants, coronaviruses, but even amongst other viruses. So what that means is that this is, of course, going to diminish the viral production, because virus infected cells will be killed. That is reducing the production of the virus. So what you see right now is that you start to see, and this is phenomenal, all kinds of mutations, not only in spike, but in other viral proteins. And whatever viral mutation that is now able to increase the transmissibility of the virus, whether it is through enhanced replication, whether it is to improved, accelerated synthesis of the virus, whether it is through, entry mechanisms into the susceptible cells other than through AC2, so non-AC2 receptor mediated entry into the cell. All these mutations are taking place, even tropism for other organs, for example. So any mutation that is now capable of increasing the transmissibility has a right to run and has a right to play and has a right to compete. And that is what we're seeing right now, that if you look what the mutation spotters on Twitter, for example, are publishing, it's amazing. The kind of mutations that you see right now in all kinds of viral proteins with, very, very strange, and they call them very often cryptic or private mutations, unprecedented. So the rule is now we have put immune pressure on the virus that is no longer selective. It's no longer selecting a certain protein because it is directed against a universal peptide. So that is not specific, it is shared, it is conserved.
So let me
But,
just clarify something there.
yeah,
Are you saying that you are anticipating that there are going to be mutations on that universal peptide as
no,
well? No,
no,
that will
no.
remain the same.
That remain, and therefore the only thing, the virus cannot change this. The virus cannot change this. So what it needs to do is to have compensation mechanisms, and it starts to introduce mutations in all kinds of different viral proteins. And anybody can play, provided he contributes to better transmission, because the transmission is of course threatened. The transmission of the virus is threatened because of the ctls. They are seriously reducing the production of the virus, and so the virus is under high pressure, non-selective, and starts to, well, I would say any mutant that pops up, which can always happen, of course, that pops up and that happens to have a fitness advantage in the sense that either it can better replicate, faster replicate, synthesis of the viral proteins occurs much faster, it can more easily enter into susceptible cells because it does not require the AC2 receptor, for example. All this, or it can better replicate in other cells, for example, the intestine rather than lung cells. All these mutations have a right to play because they all help the transmissibility of the virus, and that is what we are seeing. That is what we are seeing right now.
Well,
Now,
quick question,
yeah,
just quick question then. So what I don't understand is if the CTLs, the cytotoxic T cells, are clearing virus infected cells and they all have this universal peptide, why is it that the body is not completely cleared of virus? Is it just that it can't do it fast enough?
well, yeah. I mean, it can only, the CTLs, as I was saying, can only react once once the cells get infected, right?
Hmm.
Once the cells, and Philip, very importantly, that is key. These CTLs that are triggered have no memory. Okay, if they had memory, then by the time the virus would infect the cell, and during when the virus start to produce viral proteins, before even the progeny is ready to go, when it starts to synthesize new proteins, some of these proteins are presented on the membrane of the infected cell, right, on MHC class
Mm.
1 already. A memory cell would at that point immediately recognize that cell and kill it before it can even produce progeny, right? And that is why I've always been saying that the fact that people are saying we are protected against corona because we have these conserved epitopes, from previous coronavirus infections that are clearing the virus, it's not true. So this clearance has no memory. So that means that there is no memory cells, so they will not very rapidly recognize those infected cells. And the virus will have a chance to reproduce, to start reproduction before the ctls can even kill the virus infected cell. That is one
So,
thing. And the other
yeah.
thing is, of course, the crazy transmission that you get, because many of these people are now only having mild, very mild symptoms or asymptomatic, and the virus is highly infectious. You combine all this, you can understand that the virus is very easily is spreading.
And so I just need to make sure I understand that bit about the cytotoxic T lymphocytes. So these are not memory T cells.
No,
I see. So
they are not
this is
memory T cells. No,
they're
no,
not
no.
memory T. So well, why wouldn't the body make memory T cells to the universal peptide? They don't. That just doesn't happen. The memory T cells will respond to
It
the
just
spike
doesn't
protein.
happen. It is very complex, Philip. If you look at that sequence, what is fascinating about that sequence? What is fascinating? Well, is that this is in fact a peptide that has a high level of mimicry with a self peptide of the body, right? And you could, in fact, I mean, just to make things simple, when a virus infected cell, or when any, for that matter, any cell is presenting that peptide, you know, on an infected cell or even on a cancer cell or something, there is kind of like a signal that that cell should be killed for risk of inducing autoimmunity. So it's a self-mimicking peptide, and it will trigger the cell to kill the cell that presents the self-mimicking peptide, but it will not develop memory. If it developed memory, there would be even a risk of autoimmunity. It's
I see.
only it's only, Philip, because large virus complexes are now internalized into the antigen presenting cells. It's only when you get a huge amount of virus that gets internalized into antigen presenting cells that this self mimicking peptide will be presented in a concentration on the surface of the cell that is high enough to trigger the CTL responses. Low internalization will never lead to these non-memory cytotoxic T cells. So that is but this is the key during natural infection. It's also what happens, but the complexes are not built by low affinity antibodies. The complexes are built by the normal IgM antibodies. But that is what explains why these infections are, naturally speaking, acute, self-limiting. But you can get reinfected, right? You have memory for your antibodies, but if you have another variant and the antibodies do not work anymore, don't count on your T cells because there is
I
no
see.
memory for
So
them.
so let me just make sure I got this right. I've got
Yeah.
this image back up again. So this is the BA2A6. Now, what would be happening, because this would be mutating all the time. And so all of these mutation points. So you would have made antibodies, say, to this part, then it mutates. So those antibodies no longer work. And your memory T cell no longer works either. So the body's normal immune response is suddenly very unfocused and unable to target the spike. And therefore, what you seem to be saying is you are at last line of defense with cytotoxic T lymphocytes with no memory that can only come in after cells have been infected. So we are at a point where the immune system can no longer efficiently work. Is that essentially what you're saying?
Yeah, well, there is one last step, of course, Philip. There is one last important step, which is, remember, the vaccine breakthrough infections that ultimately have led to suboptimal immune responses. We were talking about lower affinity, we were talking about decreasing neutralizing activity, etc. But they did protect against severe COVID disease, right? This is the story about the non-neutralizing antibodies that prevent the virulence of the virus. So as long, imagine, as long as you could do anything through vaccination or whatever, and you could safeguard, you could guarantee that protection against severe disease, I mean, many people would, feel reassured and say, yeah, okay, maybe I can get the disease, but I cannot get a severe disease. I will not be hospitalized. I will not die from COVID. No, I mean, the virus will not spare the immune system, because the next step that is following now after the ctls is that the virus is going for the non-neutralizing antibodies and also make those unable to do their job. And when that happens through a new variant, then we have achieved the very last step of protection. Because
And
then
so
also protection against severe disease is going to come down.
And so this is just really like a toss of a coin because you don't know which variant is going to produce which change that could be. So say for instance, the one I'm worried about is that the Omicron variant uses a different entry mechanism, uses endosomal entry. And it seems that the vaccine antibodies block the original, which was with TMPRSS and the furin cleavage site. What I'm worried about is will one of the variants then recapture that ability to be able to use this original entry, which means they go very deep in the lung, because Omicron tends to only be in the bronchi and so on. And so it causes more of a bronchitis. But the ones that can go all the way down to the alveolar cells are then going to trigger more like a subacute kind
Hmm.
of COVID picture. Is it just a matter of the throw of the dice in terms of when that happens, based on what you're saying?
Well, what we know is that, because that is simply something we see, is that when you think about, for example, the pre-Omicron era, things were going relatively fast. We saw Alpha, we saw Beta, we saw a few months thereafter Delta, and a few months thereafter Omicron was there. So it was pretty rapid. What we are seeing right now is that things are going much more slowly. And that is explained by the fact that each time the virus breaks through the protection of the vaccinee, there is a kind of compensation mechanism operated by the immune system. It's not at all optimal. So it is not, in fact, solving the problem, but it is delaying the problem, right? It's delaying the problem. But at one point, and that is the critical thing, we come at a point where, in fact, the only protective mechanism that remains is the protection against severe disease. So, as I was saying, it goes all pretty slowly. But that protection against severe disease, we know what it is due to. It is due to the binding of the non-neutralizing antibodies. And you could maybe again put up the scheme that you showed earlier, which is binding to a site that is conserved amongst all variants, not across all coronaviruses, but across all variants. No, I meant the spike with the N-terminal domain. And that site that is conserved amongst all the variants is situated within the N-terminal domain of spike protein. And so something should happen that prevents in a new variant, that's what I mean, that prevents those non-neutralizing antibodies from binding. Now we know that this antigenic site cannot be changed. It's conserved, it cannot be changed. Why not? Because it is of critical importance, like we have seen with Omicron, that when the virus is experiencing huge pressure, immune selection pressure from, the immunization, it should have the capacity, on top of the different mutations, to use antibodies that can enhance the infection. The non-neutralizing antibodies have an infection enhancing effect. That's what we call antibody-dependent enhancement of infection. So that function needs to be safeguarded. So that cannot be changed. And therefore, what I've been postulating, what I'm pretty much convinced of, is that the only way you can change this is by glycosylation. And so by the insertion of additional sugar chains on the virus, and that this will be the type of change that we will be seeing in a new variant that all of a sudden can now also sideline the last line of immune defense, which is the protection by the non-neutralizing antibodies against virulence. And to your point, what is this? In fact, the virulence is conditioned by the transfer of the virus from dendritic cells that transport the virus to several different organs to the susceptible cells in those very organs. That transfer is inhibited by the non-neutralizing antibody.
So can I ask a question on that? So with what you're saying, you could find somebody arguing, saying, well, that proves the point. By vaccinating, you get more higher levels of these non-neutralizing antibodies. It doesn't matter so much that they are not specific. Why then would you, what is your thought, I should say, with regards to, well, that should fit public health argument, we need more vaccines. Is that logical?
No, well, that is where, of course, Philip, the complexity comes in. That is where the complexity comes in, because now what happens is, well, I told you about the ctl responses, right? All of a sudden, what you see right now is that the guys that are most competent in terms of virus transmission, like GN1, for example, right? These lineages, they are promoting the absorption of the incoming virus to the dendritic cells, to tissue-resident dendritic cells, to migratory dendritic cells, away from internalization into antigen-presenting cells and generating ctl responses. So the incoming virus, normally what happens is that a virus gets internalized into antigen-presenting cells like any foreign body. What happens with the currently dominating lineages like GN1 is that, thanks to mutations, they have more they can generate more inflammatory reaction, and that is through their ORF, open reading frame proteins. And because they generate more inflammation, the increased inflammation is going to upregulate lectins on the dendritic cells that will then strongly bind to the carbohydrates, the sugars of the virus, and you will have more and more absorption of the virus to antigen-presenting cells, because dendritic cells are antigen-presenting cells, instead of internalization. Less internalization, you have more absorption, so you are exhausting now more and more the non-neutralizing antibodies, because the non-neutralizing antibodies have the task to prevent the transfer of all these absorbed viral particles to susceptible cells. So the more absorbed viral particles, the less, in fact, the local concentration of the non-neutralizing antibodies. That is one thing. And then to your point, because you have now fewer ctl responses, you get now more and more CD4 T cell responses. And as I was saying, if the internalization is no longer massive of these complexes, you will no longer have ctls, but you will have more and more CD4 T cells that have no longer a helper function, but that, in my humble opinion, are the reason or potential reason for causing autoimmunity, right? The CD4 T cells. But because their helper function is lost, the non-neutralizing antibodies will no longer receive a boost. So they are no longer boosted, and you get more and more consumption of these antibodies because the winning guys like the GN1, and you will see, will continue to dominate whatever other mutants are popping up. When that happens, you see that the concentration of the non-neutralizing antibodies becomes more and more rate limiting. So in other words, the concentration of the non-neutralizing antibodies is becoming suboptimal in terms of preventing virulence, right? And that suboptimal concentration is, of course, exerting immune pressure on the virulence of the virus, because these antibodies are responsible for inhibiting, preventing the virulence.
I just want to show something here, Gert.
Yeah.
Again, from the same paper. And again, it kind of confirms after this is what they found with BA2.86 after the booster dose at the baseline, what they're finding. So if you look here, 16,000 against the original variant versus against BA2.86, only 304. So you're talking about the primary response is still non-neutralizing at the original variant. And if that same person was to get an infection 6 months down the line, it shifts up. So you have a response of antibody. But again, this increases about 3 times. But this is 35,000 again to the original variant and multiple other variants that are no longer in circulation. So only a small fraction of their antibodies are targeted to the specific spike protein
Yeah.
of the variant, you know. So
But there is something that is even more interesting. So as a virologist, Philip, I start wondering why all of a sudden they're only showing neutralizing antibody titers. You may know that the neutralizing assays are way more complex than doing an ELISA, for example, right? If you would do an ELISA on this sera, so what you would do, because the original neutralizing antibodies were directed against the receptor binding domain. So you take a receptor binding domain subunit, you stick it, on a plate, and you come with your antibodies, the antibodies of these patients or of these people. What would be the signal? The signal would be completely zero. These antibodies are erroneously still qualified as neutralizing antibodies, but they do no longer interact with the receptor binding domain because of their low affinity. All they can still do is recognize the entire spike code on the virus. They still recognize spike, but not individual receptor binding domain units. So they have low affinity. They are kind of like building a shield around the virus. This is avidity binding, multivalent binding, and that is inhibiting the infection. That is true, but it has not a real, a really neutralizing effect. That's why I call them subneutralizing or pseudo-neutralizing. And it's very funny because this is very misleading. Usually you always see ELISAs. Here, all of a sudden, they're not showing ELISAs, and they're saying, oh, you know what, they still have, subneutralizing activity. First of all, it's not. So these antibodies, in other words, do not compete with AC2 for the virus. They are not competing with the AC2 receptor. They engage in multivalent binding around the virus. This is biophysics, right? Low affinity, high avidity, and by binding the shield, they can still prevent the infection. But as the affinity is low, as still as you start diluting these antibodies, or as still as as soon as they decline in your body, they lose completely every single activity, right? And that is why you see very, very rapidly these decline. So it's all very, very misleading. Unfortunately, frankly speaking, I don't know whether they do this on purpose or it's whether just by naivete. I don't know, but yeah.
Well, these days you have to almost assume it's on purpose. But listen now, Gert, because I'm going to be coming to, I guess, your prediction. But before we come into that kind of thing, I wanted to ask you your thoughts about the fact that we are hearing more and more in the news about this new um, uh, uh, influenza variant H1N1 that is spreading among the animals, and then there's a risk of human crossover. And they are predicting that this could cause 100 or 1,000 times worse deaths than COVID. Do you think they're covering for the fact that your prediction is going to come true, or is this a real possibility?
Well, there are two things I would like to say to this. First of all, my prediction is very, very clearly that when the new coronavirus emerges that I'm predicting, and you hear me well, I'm no longer talking about the variant. I'm talking about the coronavirus that will have a completely different protein profile, amino acid profile, as well spike as many viral proteins. On top, will have a lot of additional glycosylation that will no longer make it a SARS-CoV-2 virus. It will still be a coronavirus, but a completely different type. Those who do not follow the evolutionary dynamics of the host pathogen interaction during this immune escape pandemic, they will of course say, see, we predicted this, that we would have to deal with a new pandemic and with a new virus. That virus, that coronavirus, would be the direct consequence of the immune escape pandemic, the evolution of the virus initiated by the mass vaccination during a pandemic, and then the vaccine breakthrough infections which were perpetuating this continuous immune escape with immune responses that were delaying the whole process, but not solving the problems, and delaying, interestingly enough, probably, Philip, to give time to the non-vaccinated population to get better and better trained so that ultimately they could provide herd immunity, right? Think about this. Why would a virus delay this? Why would you, after vaccine breakthrough infection, and all of a sudden the immune system comes back? Okay, when you come back, solve the problem, for God's sake. They cannot solve it. The immune system cannot solve it. The virus comes back again. Then the immune system comes with the CTL responses, right? And still not solving the problem. So what is happening, in fact, that's not an efficient process. It's just delaying the whole thing. Well, this delay is there for some reason. And that is the reason I think, nature is, safeguarding the species in that way. So, but I didn't with that. Oh, yeah. Okay. So that is one option. The other is with the CTL responses, and people can look on my website. I wrote 2 or 3 articles, I think almost 2 years ago, where I was saying when these CTL responses, when these antigen presenting cells are now hyperactivated, because this is currently the major arm of the immune system to keep coronavirus SARS-CoV-2 under control, is massive CTL responses. But these CTL responses, as they recognize a universal peptide that also happens, people can look this up, that happens to be present in the infectious protein of other viruses, like, for example, RSV, like, for example, influenza, we cannot rule out, I cannot prove this, it's theoretical, but I think it's certainly a possibility. We cannot rule out that people infected with influenza, which normally is symptomatic. When you get infected with influenza, you normally develop symptoms. But because of this hyperactivation of CTL responses due to the coronavirus infection, these CTL responses will also render or could render the flu infection asymptomatic. So people will spread it without even knowing it. And within no time, you get, of course, a high infectious pressure, a high level of viral infectivity that could then, of course, promote, let's say, the spread and could even become, of course, very dangerous. I don't know whether this is the underlying mechanism, but it is clear that all these things are connected. It's not for nothing that this is called the universal peptide. It's not for nothing that this is a very same in all these viruses, the very same self-mimicking peptide. Why would viruses incorporate self-mimicking peptide? It is to have access to this, answer of last resort or help of last resort, which are the CTL responses. So this could be an important factor in rendering a number of these infections asymptomatic. And I wonder whether the wave of RSV infection, even monkeypox, that we have seen, because, interestingly enough, it all happens in highly vaccinated countries, right?
Yeah.
Monkeypox is not typically, a virus. It's more typically a virus from Africa.
Yeah.
So there are certainly very, very different interactions going on. Other people would say, yeah, the immune system is suppressed or is derailed. We see more and more immune pathology that could make people more susceptible to other infections. We have already seen flare-ups, for example, of chronic infections like Epstein-Barr, cytomegalovirus, etc. So it's extremely complex. But again, the bottom line is when you fundamentally, at large scale, disturb population immunity, then the consequences are just huge because everything is connected. It's all interconnected, right? And that is what we have been doing, complete immune dysregulation at large scale. And, one shouldn't be surprised that this has consequences, not only with regard to how nature will restore this balance with regard to SARS-CoV-2 and coronavirus in general, but also with regard to impact of the emergence of other infectious diseases. And as we have seen, due to the immune pathology, even non-infectious immune-mediated diseases that are now increasing in prevalence, like cancers, etc. So all
Yeah.
this is a very complex puzzle, right?
So what I wanted to do for me, Gert, because as I said, some of the stuff is quite complex. I've got here this image, and I want you to just take us through it before I ask you to summarize what you predict is going to happen. So if we look at this here, yeah.
Yeah,
So you started with the Wuhan lineage. There was the large scale infection prevention measures. It became
yeah.
more infectious. Then you had large scale vaccination. And you're seeing here non-neutralizing antibodies
No,
were
no, neutralizing antibodies. These are the
neutralizing antibodies.
yeah, of
Yeah.
course, induced by the vaccine, very clear.
Yeah. And so then you have highly selective immune escape, which, based on your theory, was the creation of Omicron, which is now poorly neutralizable by the vaccine. Now you're saying here, so then Omicron, because now you have poorly the PNNAB, just clarify again, what is this?
Yeah, these are the, well, polyreactive, yeah, but people
Mhm.
can forget this. Polyreactive non.
Neutralizing antibodies.
And that has been, there's a number of publications on this, and I think the first one who came up with this was Professor Fantini from Marseille, who demonstrated that when the initially induced antibodies substantially lose their neutralizing capacity, that then, in fact, the non-neutralizing antibodies come into the play. I will not explain this in detail, but in several of my articles, I'm explaining also in my book that, in fact, the low affinity binding of the initially neutralizing antibodies to the virus is the reason why, or explains the mechanism of synthesis or induction of the non-neutralizing antibodies. But once these non-neutralizing antibodies are there, and again, Fantini and others have shown this, they bind to a conserved domain in the N-terminal, the N-terminal end of the spike. And through this mechanism, they can enhance, they can accelerate the binding of the receptor binding domain to the AC2 receptor. So they can speed up, they can enhance the infection.
Yeah. And so then
that is what causes the vaccine breakthrough infection, so to say.
So then you end up with the selective immune escape,
Yeah,
which is more infectious.
Yeah, highly selective means, Philippe, because it's directed primarily against the receptor binding domain. After the vaccine breakthrough infection, you get broadly neutralizing antibodies. They are, of course, less selective, still directed to spike protein, but not to the receptor binding domain, but to conserved. Receptor binding domain is pretty variable, to conserve to domains that are shared with other variants. So that means if that immunity becomes suboptimal, this was what we were just discussing with the non-neutralizing or the pseudo-neutralizing antibodies, then of course, the kind of immune selection that you get is no longer highly selective, but it's still selective because these antibodies are still directed to spike protein.
Explain the VBTI.
Well, the VBTI is a vaccine breakthrough infection.
Vaccine breakthrough. Okay, good.
Yeah.
So then you have the more infectious Omicron descendants, and then you end up with the universal ctls, the conserved epitope. That's what we're talking about, where the cytotoxic T cells. So is this where we are now?
Well, I think we yes, that's still where we are now. But Philip, I mean, there is one very, very important thing to follow this. I think, of course, I may be wrong, but I'm pretty much convinced that the fact that we are now seeing more and more immunopathology, I think the reason is that we are having less CTL activation for the reasons that I explained previously, that now more and more with GN1, the virus, the progeny virus, is in fact shifted to the absorption to the dendritic cells at the upper respiratory tract rather than internalization into those cells. And remember, I mean, I know you are a specialist in autoimmune diseases, etc. But so that is something you will have to confirm, not because there is a threat, but any autoimmune disease or autoimmune diseases, immune pathology always involves CD4 T cells, right? Always. And I think that the long COVID cases that we are seeing right now, it's not due to the fact that, they are saying, oh, these are immune suppressed people, and always blaming somebody, right? These are individuals that are immune suppressed and they cannot clear the virus. And so the virus is replicating. And yeah, for sure, then you get these mutants, etc. No, it's the other way around. These people are suffering from immune pathology because of the immune escape, which is a population phenomenon. And because they are suffering from this immune pathology and no longer generating CTL responses, but only CD4 T cell responses, first of all, these CD4 T cell responses could be the reason of some autoimmunity, but secondarily, they will not help you in clearing the virus, right? So to your point, if that is indicating an increased shift of the virus to adsorption instead of internalization in antigen presenting cells, namely in the dendritic cells, then we are at the phase where we have started to put under pressure the inhibitory effect of the non-neutralizing antibodies, the virulence inhibitory effect of the non-neutralizing antibodies.
So, in effect, you're saying that this is suggestive that we are at this point here.
Yeah, and that's what
Yeah.
we see, and that's what we see. I mean, that's not me
Yeah.
speculating. I have a theory, and what I do is I will always verify because there is little reports, and now you have to go on Twitter, you have to follow these mutation spotters, etc. But what we are seeing is that the virus are now competing on the base of transmissibility, and whatever mutation you come up with, but you manage to be more transmissible or to some extent more transmissible, you are in the race, you can compete. Some of them do not compete very well. We call them cryptic variants. Why do they not compete very well? Well, nowadays, Philip, to stay in the race, you have to to match several criteria. You have to be resistant against neutralizing antibodies. We agree. You have to be more infectious. We agree. You have to be able to generate more virus, to be more productive, because the ctls, they are in fact inhibiting viral productivity. And so when you come up just with more productivity, okay, you can stay in the race for a while, but you are going to be outcompeted by the guys who match all the criteria and the resistance and the more infectious, and better productivity, etc., etc. And that is what we're seeing right now. Some cryptic variants, they are very local, they come and go, but they can be very weird. They have mutations. Oh my God, never seen. Not in the Gizate, the database or whatever. So that is what is currently happening.
Yeah. Okay. So now I want to understand this bit because this is the important bit that I heard you say for the first time. So I want to make sure I got it right. So at some point, you think that it is going to then produce this HIV cron, a highly virulent coronavirus that
Yeah.
is not SARS-CoV-2. Is that
Well,
what you?
yeah. So, Philip, I mean, to make things easy to understand. So, if you have reached the maximum of transmissibility, right, is the you continue to put the virus under pressure. The virus, has become non-neutralizable. It has become more infectious, and it has become more transmissible. That's what we were talking right now. What you will see is that GN1 or descendants of GN1 will win this race, but it's slowly, because every single time that you have new cryptic variants that can stay in the race for a while, they can compete to some extent with GN1. So, its dominant propagation takes longer. But what we will is that you will see that the spectrum of variants that are circulating in the population will narrow down. It will narrow down to GN1, to one or two strains. But then what is in fact happening is that the I'm trying to remember your question.
With regards to the evolution of that highly infective, almost different coronavirus, that
Yeah, well, yes, of course. So when the transmissibility has reached a maximum, and already like 4 months ago, when GN1 popped up, virologists were saying we cannot imagine any higher degree of transmissibility or infectivity than GN1. So when that maximum is reached, so that means that the virus has reached the maximum capacity of spreading from one host to the other. If
Mhm.
that is reached and you put it further under pressure, the only way out is to be highly transmissible, not from one host to another, but within the very same host. And that transmission would translate, not in a transmission from spread from one host to the other, but a dissemination from one organ, the upper respiratory tract, to all the organs, right? So instead of spreading inter-host, it will spread intra-host. That would still increase the productivity of the virus. And the only way to do this is to cut off the attachment of the non-neutralizing antibodies to the virus, right? And that is what I think, because that antigenic site within S and TD is very conserved, cannot be changed. So the only way to do this is, I call this not steric immune refocusing, I now call it steric immune silencing. You can expand the glycans, the sugars on the membrane of the virus. So, and you know, the sugars cannot be recognized by the immune system. And you could sterically prevent the attachment of the non-neutralizing antibodies. Amazingly enough, very few people, almost nobody, is talking about the glycosylation of this virus. It's like, you know, this virus is glycosylated. 40% of of the surface is covered by glycans. So the
And
glycans,
that just means is that sugar molecules attached onto the protein molecules so that it hides the antigenic sites. And
yeah, well, it's more complex, but
yeah,
by movement of these chains, it can block the access of the non-neutralizing antibodies to the antigenic site. And interestingly enough, so what happens, and it's also described in many virology textbooks, is when you get this additional glycosylation, that very often the virus will pay a price in terms of diminished fitness, right? Less infectiousness. Not a problem, because this mechanism, I described this in an article 2 years ago, this mechanism will only prevent access of non-neutralizing antibodies to this conserved antigenic site that is displayed on viral particles that are attached to the dendritic cells, but not to the free circulating particles. And because, you know, this steric hindrance would not take place, and I'm explaining the putative mechanism in this article. It's not something that I'm just like, it's not like pure fantasy. But on the free, in the free particles, the antigenic, conserved antigenic site would still be accessible for non-neutralizing antibodies, so that they could still enhance the infectiousness of a virus that has now, in terms of effectivity, been debilitated through additional glycosylation. And that is why
so
I will call this, what will happen, in my humble opinion, is not only severe disease. That's what happens when the non-neutralizing antibodies come off, but because of the infection enhancement, enhanced severe disease. And that is why I'm saying, people, we need to be prepared. Maybe we will not have the luxury of waiting till symptoms appear and then do treatment, but do it prophylactically, antivirals.
and so when it comes down to the crunch then, and you're feeling I always hesitate when timelines come up
Yeah,
because timelines based on clinical stuff, you can't even predict when a patient is going to die, when they're supposed to die,
no,
when they're on end of life. People's immune system and body is so resilient sometimes that it is
yeah,
very
yeah, it is
difficult to,
resilient, Philip.
yes.
I mean, we have spoken about the resilience. You know, first, you know, after the non-neutral, the neutralizing antibodies, you know, the host immune system came up with the broadly neutralizing antibodies that were still capable of inhibiting the infection. Then, when that didn't help, but only delayed, it came up with the ctl responses. When that was no longer working very well, and that's what generated immune pathology, in my opinion, because, you know, they are now shifting away from internalization into antigen-presenting cells to adsorption to the dendritic cells, there's still resilience. The non-neutralizing antibodies still prevent the severe disease, but there is somewhere a limit. There is somewhere a limit. And I guess what I'm saying when I'm now talking about timelines is that we are really in the very, very last stage of the virus. We have seen this overnight with Omicron. Okay, that was not with regard to virulence, it was with regard to neutralization. All of a sudden, nobody expected this. Overnight, Omicron was there. A huge change. 30 or 32 mutations within almost like the same domain in spike, right? Unbelievable, unprecedented, to an extent that some conspiracy theorists were saying, oh, see, now they fabricated this virus, because nobody could believe this. Yeah, if you don't understand the evolutionary dynamics, if you don't understand what immune pressure is, if you don't understand that this immune pressure is exerted by an entire population, then of course understand this thing. So I expect something which is at least in terms of the conversion as spectacular as Omicron was, but the difference here will be that it's no longer the play about being more infectious or less neutralizable. It's about who is more virulent, and that is what the virus will have to go for. So I have no problem if you ask me to repeat the timelines that I have been sharing in writing, but people should understand that when I say these timelines are in very near future, what they should understand is that, and that is what we try to explain, that we have really reached now the ultimate defense, or the immune system has really exhausted its last bit of strength of defense. So people should understand this, that it is really, it's not going to be, like another immune refocusing and something else will pop up, etc. As a scientist, having studied this like for 4 years now, I'm convinced that this is not going to happen. That is one thing. The second thing is that those who think I'm just, I'm just crazy, I'm freaking out, and I'm a jerk, that's all fine. But those who think something could be possible according to what I'm saying, I would really urge them to start preparing, because there is no doubt that this will generate a huge chaos, right? To begin with the hospitals and the healthcare system that will crash. But I admit it's very difficult because it's insidious. Right now, there is no increase of acute COVID-19 cases. There is no increase in acute hospitalizations or death. Wastewater levels are still relatively nobody is talking about it. Everybody's distracted, focusing on side effects, focusing on lawsuits, etc. But that is, I cannot say otherwise than I've been warning people that society in highly vaccinated countries will be caught by surprise. And this is kind of like the silence before the tsunami. And Philip, you know me well enough. I know that I'm not into sensation, right? This is what the science tells me, and that is why it's frightening. It's really frightening. If some nerd is talking, is saying this, or some people who have a lot of fantasy, then you can put this in perspective. But this comes from somebody who has been studying vaccinology, immunology, infectious diseases for 30 years, has taken an enormously deep dive. All my time goes in studying this for 4 years. So that I don't claim credibility, no, but people who are hesitating, I would really encourage them to seriously think about this. And yeah.
So let me ask you a question then, because this is what I can see in the comments, some of the questions people are asking. Because this is not necessarily the same for everybody.
No.
How do you break this down? I tend to have a number of groups from an immune point of view. there are people who have good natural immunity, okay, and they haven't been vaccinated. Then in the people who haven't been vaccinated, there are people who have what I think are interferon autoantibodies that inhibit their natural immunity, and they are at a different kind of risk. And even within the vaccinated cohort, you have people who have good natural immunity that hasn't really been affected even after vaccination. And then there is a big cohort of people whose immunity is too focused. Who is affected, and what do you think that would look like?
Well, it is easy to have some people, or to put some people, in a black or white group. That is easy. For example, if you think about the unvaccinated who are in good health, um, I see absolutely no risk whatsoever. And when push comes to shove, I'm willing to prove it. I'm willing to prove it, to expose myself, right? No problem. Of course, unvaccinated people who are frail, who are not taking care of their lifestyle and their health, etc. Um, I don't even think they will succumb to severe disease, but they will get the disease because, nevertheless, virus is infectious, right? It's pretty highly infectious. Then the other thing, or for example, the elderly people, these are the people who were first vaccinated. Many of them in not only hospitals but daycare homes and nursing homes, etc. They were vaccinated before even having seen the virus, right? So they have not been exposed and they were immediately vaccinated. And many of them with mRNA vaccines. I'm explaining that in my lecture, that mRNA vaccines are speeding up vaccine breakthrough infections. And that is very, very bad. It's just enhancing the immune escape. So the elderly who have been vaccinated right at the beginning, got the full vaccination, 2 shots, 3 shots, even more shots, they are very, very, very seriously at risk. And then, of course, you will have a gray zone, but all in all, I must say the highest risk factor are combination of mRNA vaccines, or full vaccination, for example, at least 2 or even 3 shots, or being vaccinated before having been exposed to the virus, for example. So these are definitely all factors that are going to increase the risk. The problem is that some people, they got, of course, their innate immune system trained before they got exposed. But remember, this is a race where you cannot afford missing too much of the training, because the virus got more and more infectious, right? And every single time, for example, unvaccinated people at the beginning, they got also ill. Of course, they got ill. And even till recently, some people got some kind of disease being unvaccinated. But the more we get trained and the more we get exposed to these highly infectious circulating variants, the more our innate immunity is so robust that it kills the virus right at start, like, Philip, the T memory cells would do. The NK cells, when they are trained, they can do this right away, namely killing a virus-infected cell before it produces progeny, right? So, but yeah, of course, there will be a gray zone, and people ask me for numbers, etc. I cannot do this. I will not do this. But let's be very, very clear. I think very seriously that the threat is imminent, and we will, unfortunately, I hate to communicate this, we will need to be prepared to very substantial, unfortunately, substantial losses. I mean, this equilibrium, this balance between the host and the pathogen has been fundamentally disturbed at a very, very large scale. Nature is phenomenal and can restore this and can end the pandemic, completely end the pandemic. But the price we will pay will be much, much higher than if we had not put the virus under pressure without being able to control it. That means not generating herd immunity and doing instead this stupid mass vaccination. And had we then simply treated people with symptoms so that they could rapidly contribute to herd immunity, I mean, we would have had, nevertheless, some losses, of course, but not incomparable to what we are up for right now. That is unfortunately my humble opinion.
Yeah, I suspect I agree, Gert, and I myself have been concerned about that transition. I think it is inevitable.
Mm,
And I look at it, the way I describe it is in a similar way to trying to tell somebody before the pandemic had started what was going to happen. It just wouldn't make any sense. And there's
mm,
almost no point telling them because they wouldn't believe you. And so,
yeah,
yes, I do agree that this transition is difficult to know exactly when, but
yeah,
all the indications are that it has to happen at some point.
yeah.
And I
Yeah,
can't
and
even
that is
say
not even
yes.
talking about the immune pathology, because that is
Yeah,
also still important to know for the audience. Whereas people at the beginning thought it was all not related. I mean, people have to understand that the consequence of this, mass vaccination with Omicron causing vaccine breakthrough infections, you have immune escape, and in tandem, you have immune dysregulation.
yeah,
So the immune pathology and the immune escape are directly related, right? You cannot disconnect them. And what we have seen is first immune pathology due to the antibodies, IgE4 antibodies. Now that immune defense is shifting to CTL responses or T cell responses, but not in a perfect way. You will see more and more immune pathology due to T cells, for example, right? That's also shifting. The immune escape is shifting. The immune response is shifting. The immune pathology is shifting from antibody mediated to more cell mediated, etc. So that will also and is already to some extent, there's an euphemism probably, the cause of the excess deaths that we are, of course, observing in a quite alarming way.
yeah. So yes, again, Gert, deep, complex things. I'm sure I'll
Yeah.
find Rob at some point, and we'll go back over quite a lot of what you've said there. But yes, I think that we've had a good opportunity to listen to the theory. Before we close out, I just want to remind everyone again, if you are interested in joining us on this journey, what is disease X. And based on what Gert is saying, I agree with him, it's going to be some strange variant of the coronavirus. What can you do? So, yes, if you want to join us, click on the link. It will also have all of Gert's interviews for the past few years. I've had a tremendous honor listening to Gert over this period of time. So, click on the link below. So, Gert, final words as we close out?
Well, yeah. Final words. As I was saying, Philip. I mean, I'm myself in state of alarm. I think this is going to happen pretty soon. Let's be very open, and I will not. I promise, I will not change these timelines. Of course, I don't know exactly, but I'm focused on this thing taking place before the end of June. And I can only recommend we have to do this is that vaccinated people who think they are really at risk, that they, soon as we see the first signals in whatever country, because if it starts in one country, it will spread very, very rapidly, to take antivirals prophylactically. And of course, I'm praying myself that I'm wrong. I'm not interested in sensation at all. But and I could also shut my mouth But what can happen to me is only that I lose completely my reputation, that people ridicule me when if I had been wrong, etc. I'm completely willing to pay this price. But on the other hand, if my warnings have contributed to the health and life saving of people, then for me it's all worth it. So these are my final words.
Excellent. Excellent. Thank you again very much, Gert. I'll ask you to hang on with me. Thank you, audience, for being with us for this time. I appreciate you staying with us. Have a great evening until we speak again.